In this media, you're going to see about the behavior of AC resistive circuits. Resistors are passive devices which do not produce electrical energy. The resistors dissipate the electrical energy in the form of heat. Now we will see a simple AC circuit consisting of a source and a resistor. The graph for voltage and the current values for AC circuits with resistance is shown. Look at the graph. The voltage and the current are in phase. Since the resistor directly resists the flow of electrons, the waveform for the voltage and the current are in phase in a purely resistive circuit. When instantaneous value for current is 0, the instantaneous voltage across the resistor is also 0. Likewise, when the current through the resistor is at positive peak, the positive peak of the voltage across the resistor also occurs at the same time. In a purely resistive parallel AC circuit, the total circuit current is equal to the sum of the current through all branches because they are in phase with each other. In a purely resistive series AC circuit, the total circuit voltage is equal to the sum of the voltages across each resistor because they are also in phase with each other. The power consumed by the circuit can be found by the product of voltage and current, that is, P equals V sub RMS times I times cosine phi in watts. The power factor cosine phi equals 1 for the AC circuit with resistor, since the phase angle between the voltage and the current is 0. Since the value of cosine phi equals 1, then the power consumed by the resistor is given as P equals V sub RMS times I. The power in a purely resistive circuit is always a positive value. When the voltage is negative, the current is also negative, and vice versa. Hence, the power is always obtained in positive value. The positive polarity of the power in the AC resistor circuit indicates that the resistors always dissipate the energy. The current in the resistor, lowercase I, equals uppercase I sub m times sine of omega t, and the voltage, lowercase v, equals uppercase V sub m times sine of omega t, where uppercase I sub m equals peak current and uppercase V sub m equals peak voltage. Lowercase v equals lowercase I times r by Ohm's law. Therefore, lowercase v equals r times uppercase I sub m sine of omega t. From 1 and 2, uppercase V sub m equals r times uppercase I sub m. For an AC circuit with pure resistor, the peak voltage value, V sub m, is r times the peak current value, I sub m. Thus you understood about the characteristics of resistor in an AC circuit.